Projectile motion is the motion of anything under gravity. So when you are throwing a ball, so suppose you have a ball in your hand and you're throwing it, it moves in a path something like this. It's called a parabolic path, and you have gravity acting on it throughout the journey. So this white sketch is the path that the ball takes to the ground. This would be more complete. This is the ground, so it moves in a way like this. The shape of this path is called parabolic, and throughout the journey you have gravity acting on it, and the force of the gravity is just the weight of the ball. So before we go on to projectile motion, we need to know about the SUVAT equations. SUVAT equations are 5 equations that we need to know when an object experiences constant acceleration. Projectile motion falls into this category of constant acceleration because the weight of the object does not change, so this force will not change. The mass of the object also doesn't change. The ball doesn't lose weight or gain weight when it's flying, so the acceleration must be the same throughout the journey. Now the letters in SUVAT means this. The S stands for the displacement, the U stands for the initial velocity, the V stands for the final velocity, the A for acceleration, and the T for time. Now the equations that you need to know are this. The first one is the most basic. It's V equals to U plus AT. So the final velocity is the initial velocity plus acceleration times time. The thing that you need to remember more is which term isn't included in each equation. So in this equation, we don't have S. So we don't have displacement in this equation. So if we don't need to work with displacement, we will use this equation. Now the second equation is S equals to U plus V divided by 2 times T. In this equation, we don't have acceleration. So when we don't need to work with the acceleration, this is the equation we use. The third equation is V square equals to U square plus 2AS. In this equation, we don't have the time. The fourth equation, we have S equals to UT plus half AT square. In this equation, we don't have the final velocity V. And finally, the fifth one, which in most cases you won't need, but it's S equals to VT minus half AT square. And in this, you don't have the initial speed, initial velocity. So these are the 5 equations, the 5 SUVAT equations. Now, before we go into discussing projectile motion, another thing that we need to know is that horizontal and vertical motion are independent of each other. And if I draw the same scenario again, you are throwing a ball and it's landing on the ground. We'll assume that there's no air resistance. So the only force that's acting on the ball is its weight, that's downwards. There are no horizontal forces on it. And we need to remember that at 90 degrees, the motion is independent. So this is what we need to remember, that the horizontal and vertical motions are independent of each other. One does not affect the other. So whenever we have a problem of projectile motion, we'll divide it into the vertical and horizontal motion. In horizontal motion, I'll denote it with HM, horizontal motion. We have a constant velocity because we don't have any horizontal forces acting on it. Whereas for vertical motion, we have an acceleration equal to minus g. Now, if we are given the angle and velocity at which it was thrown, so suppose it was thrown at 30 degrees with a velocity of 10 meter per second. We need to divide it into vertical motion and horizontal motion. In horizontal motion, the only thing we need is the velocity. In vertical motion, we need the initial velocity. And later on, we'll use the other stuff. We also know the acceleration. The acceleration is equal to minus g. This is what we know at the start. So if I have 10 meter per second at 30 degree to the horizontal, I can figure out the horizontal and vertical components. For the horizontal component, we can use trigonometry over here. So this is a right angle triangle. The horizontal motion is over here. It's the adjacent to 30 degree, whereas 10 is the hypotenuse. So cos 30 degree would be equal to the adjacent, which is the horizontal velocity, I'll denote it as VH, is divided by 10, which is the total. So the horizontal velocity, the horizontal component of the initial velocity is 10 cos 30. Similarly, for the vertical initial velocity, so the vertical component of the initial velocity, it's this line over here. This is opposite to the 30 degree. So sine 30 is opposite by hypotenuse. The opposite is the vertical initial velocity, so uv, divided by 10. So the initial vertical velocity is 10 sine 30. In case of horizontal velocity, I'm not using u because it's gonna be a constant velocity throughout. It won't change. So this is the initial, this is the final, this is the velocity throughout the entire journey for the horizontal component. The horizontal component won't be changing. So now we know the initial vertical velocity uv, which is 10 sine 30. I'll add a subscript v to everything in the vertical motion section and a subscript h to anything horizontal. This is 10 cos 30. Now for the flight time, if you notice, for simplicity, I'll assume that I threw the ball from the ground. So I threw it from here and it's landing at the same height. So if that's the case, the vertical displacement of the ball is 0. So if I want to find how far away the ball landed from you, so this distance over here, I'll need the flight time. And to do that, I'll set the vertical displacement to be 0 meters. And now I need the flight time. So the only thing that we don't need here is the final vertical velocity. So if we look back at our SUVAT equation, we don't have v. So the fourth equation is what we are going to use. So we use s equals to ut plus half a t square. The displacement is 0. The initial velocity is 10 sine 30. We have a times t, and then we have plus half into minus g t square. So if we move everything to the left, we have half gt square minus 10 sine 30 t equal to 0. We can take out t over here. We get half gt minus 10 sine 30 equals to 0. So we get t equals to 0, which is obvious. At the start, the ball was at level with the ground. So the t values we get are the times at which the ball is at this level, the ground level. And the second value of t will be found using this. So half gt minus 10 sine 30 is 0. Half gt is 10 sine 30. So t will be equal to 10 sine 30 degree divided by half g. If you plug in the values, it will look nicer, obviously, but I'm just showing it in this form. Now we know the flight time. The flight time is common. The time that it needs to take the reach the ground is the same time it will travel in the air horizontally as well. So they share the same time. The flight time is shared between the two, vertical and horizontal motion. So this t is the same as this t. There's no times horizontal or vertical component. Time is just time. So this time is also the same. So if I want to find how far it traveled, this over here, we call this the range. So S horizontal or range is equal to Vt. We use S equals to Vt over here since acceleration is 0. This is only applicable when acceleration is 0. So we have S horizontal equals to V horizontal, which is 10 cos 30 degree, multiplied by the flight time, which is 10 sine 30 divided by half g. And that's the answer. Now this is to find the range. We can also find the maximum height that it reaches using the vertical motion. Now if we notice, you reach the maximum height when you don't move higher anymore. Basically, at this point, the vertical velocity will be 0. So at this point, the vertical velocity is positive. It's moving up, up, up. Then it reaches a point where its vertical velocity is 0. And then it starts falling with a downward velocity. So at the point that the ball is highest from the ground, the vertical velocity will be 0. So using this, we can find the maximum height. So for max height, V vertical is 0. We know U vertical, we know the acceleration, we don't know the time, and we want to find the displacement. We want to find the maximum height, which is the displacement. So in this case, we don't care about time. So if we look back at our SUVAT equations again, the third equation is what we'll use because it doesn't include time. So we get V square equals to U square plus 2as. V is 0, U is 10 sine 30 squared plus 2 minus g times h. From here we get h equals to 10 sine 30 square divided by 2g. Now instead of values, if we just use the symbols, we can find out some general formula as well. You won't need this part, but this is just additional stuff for you if you want to know. So for the vertical motion, we have the initial velocity. The initial vertical velocity is the actual initial velocity. So this 10 meter per second is the actual initial velocity. The 10 sine 30 and 10 cos 30 are just components of that velocity. So the vertical component is sine of theta, the angle to the horizontal. So we mentioned theta being the angle to horizontal. We know that acceleration is equal to minus g. For horizontal motion, in general, we know that the horizontal motion is u cos theta. The vertical initial velocity is u sin theta, the horizontal velocity is u cos theta. Now we know that the flight time, if we want to find the flight time, we set s equals to 0 and we use s equals to ut plus half a t square. We get 0 equals to u sine theta t plus half minus g t square. The next line we get half gt square minus u sine theta t equals to 0. We take t out common, half gt minus u sine theta equals to 0. We get t equals to 0, or t equals to u sine theta divided by half g. Now for the horizontal motion, we use the same time. So the range r, or the horizontal displacement, is equal to u cos theta multiplied by u sine theta divided by half g. So this is just 2u sine theta u cos theta divided by g, which would be 2u square sine theta cos theta divided by g. However, we can simplify this further using a math trick. I'll once again give a disclaimer. This is not mandatory to know for your A-levels, for your A-level physics. You can get away with just using the SUVAT equations on its own. You don't need to find out this general form for projectile motion. So the math trick we use is this. So if you remember your trigonometric identities, sine a plus b is sine a cos b plus cos a sine b. Now, if a and b were both equals to theta, we'd get sine 2 theta. So theta plus theta is 2 theta. This would be equal to sine theta cos theta plus sine theta cos theta. So sine 2 theta is the same as 2 sine theta cos theta. If we move the 2 over on the left, we get sine theta cos theta equals to half sine 2 theta. Now we see that we have sine theta cos theta over here. We have sine theta cos theta over here. We can replace it with half sine 2 theta. So we get 2u square times half sine 2 theta divided by g, which is equal to u square. This half and 2 cancel out. We get u square sine 2 theta divided by g for the horizontal displacement. We can do the same general form for the maximum height as well. So at the maximum height, the vertical velocity is 0. For the maximum height, we don't have any work to do with horizontal motion. The vertical final velocity is 0. The initial velocity is given over here, u sine theta, and acceleration is minus g, and s is equal to the height. We don't have t over here, so we use v square equals to u square plus twice as. V square is 0 square, u square is u sine theta whole square, and then you have 2 times minus g times h. So h is just u square sine square theta divided by 2g. Or you can even leave it in this form, u sine theta whole square divided by 2g is the maximum height. I'll just write h max. And that's it for projectile motion.